The second vector multiplication function is called the cross product, and it's denoted by A vector cross B vector. And I've written here two vectors A and B. So the way we calculate the cross product is by using a matrix. The first row is going to be the coordinate components, I hat, j hat, k hat. Then the components of the A vector, ax, ay, az, and then the components of the B vector, bx, by, bz. Now, we would solve this just like treating this as a regular matrix and finding the determinant, and we can do that by cofactors. So if I have, let's do another color here. Let's do red. So if I have, for this I component, we're going to take and do the determinant of these four values. So I'm going to have ay times bz minus by times az, I hat. And now for the second, for j direction, for this j here, we're going to use this set of numbers in the first column and this set of numbers in the third column. And remember that if I do a plus on the first one, the next one's going to be minus. And I'm going to have ax times bz minus bx az j hat and for the next one we deal with k hat. We're going to use the second or first and second column, second and third rows, and we're going to have, now I'm going to go to a plus, right? Because I hat was a plus, j hat would have a minus, k hat will have a plus, and that's going to be ax times by minus bx times ay k hat. Now I can distribute this negative sign into the j component. And so that would just give me ay bz minus by az I hat plus bx az minus ax bz j hat plus ax by minus bx ay k hat. Now, what does the cross product actually represent? Well, it's a vector, so It's another vector quantity, but what does it actually represent? Well, on another slide here, I'm going to show a quick calculation and try to put this in to a three-dimensional format, and it's sometimes difficult to really tell what a cross product really does. But the best way to show it is the A vector is actually the blue, let's see, 1, 1, and 1, that is actually going to be the red. That's going to be the red. And the B vector is going to be the blue. And the cross product is green. And what you would notice here is that the angle between the A vector and the cross product is 90 degrees. And the angle between the blue vector or B vector and the cross product is 90 degrees. And the angle here between these two blue and red vectors may or may not be 90 degrees. They could be any kind of angle there. And the angle then determines the length of this vector, this cross product. So just like we had for the dot product, we have a way of being able to calculate the magnitude of the cross product by using the lengths of each of the vectors and the sine function. This is the angle theta right there. So cross products are a little more difficult to be able to visualize, but they're very important. We're going to be using them quite a bit this semester. Now, there's some characteristics about cross products that are good to know. So if I have different combinations, and let's just look at the different components, just look at the unit vectors, and numbers in front of them are just multipliers, so we can figure that out. But just to look at what kind of directions we get here. So I'm going to have I cross j and I hat cross k hat. There's 9 of these different possibilities. J hat cross I hat, j hat cross j hat, and j hat cross k hat. And then we have k hat cross I hat, k hat cross j hat, and then we have k hat cross k hat. So when you do a cross product of a vector to itself, these are the easiest. It's 0. And that makes sense because the angle between the two would be 0, and sine of 0 is 0. Now, the quickest way that I can remember how to do this is I look for things that are in alphabetical order. So if I have I cross j, I know that's going to be k. And if I have j cross k, then that gives me an I. So it's kind of like a little round robin thing going on here. And I have K cross I, that's going to be J. And now anything that's backwards is going to become the negative. So here I had K cross I is J hat. Down here I'm going to have I cross K is going to be minus J hat. I cross J was K hat. Now I'm going to have I hat, or J hat cross I hat is minus K hat. And I had J cross K hat is equal to I hat. When I flip that around, I'm going to have minus I hat. These are going to be very important when we get into magnetic fields and working with Biot-Savart. So when you see a problem that says use Biot-Savart, you will need these cross products.